Well, good morning, everyone. Welcome to another math lesson with Mr. Kalashin. Today we're doing day number 105, parallel and perpendicular lines. And that can be found on page 330 in your Volume 2 Math Notebook. Okay, today you see we have a couple of things added. In addition to your math notebook, you'll need a pencil, of course, and whiteboard or paper, and a marker if you have a whiteboard. You're also going to need a ruler and a protractor. A protractor tells you degrees of angle on corners, and of course a ruler measures distance. If you don't have these, not to worry. The lesson is designed where they're implanted in the visuals. So let's get started. And as always, please stay focused. Try to stay with me. If I'm moving too fast, you can always pause and pick it up later and replay it at your leisure. Here we go. Learning objective. Today we will draw parallel and perpendicular lines. Standard 5G3. Essential question. How can I identify and classify triangles? Let's do a little review. A line is a straight path of points that goes on and on in two directions. This is line AB. Okay? A line shows arrows at both ends because it goes on to infinity. A line segment is just a section of line, not on to infinity. So a line segment does not have arrows at the end. It just has a point on each end. A point is an exact location in space. These are all points. Point A, point B, point C, etc. A right angle is a square corner. It is exactly 90 degrees. If you kind of take your finger and your thumb and you kind of spread them out, you kind of make a right angle like that when you spread them all the way apart. So that is a right angle. That is a right angle. Squares have four right angles or rectangles. A right triangle has a right angle in one corner. Door frames have right angles. Pairs of lines are given special names depending on their relationship. So it says make motion with your arms. Well, you can't see me making the motion with arms, but parallel lines, you can have your hands together going up and down, showing that they're going the same direction with parallel lines. With perpendicular lines, you can put your hands together and make like they're crossing straight like that with two hands. So that's perpendicular. And then these are intersecting lines where they cross each other at some point. Intersecting, parallel, and perpendicular. Intersecting lines are lines that pass through the same point. Those are intersecting lines. Those are intersecting lines. The green and the blue are intersecting lines. The points where they're intersecting, where they make contact and cross through one another. Parallel lines are lines that never intersect and are always the same distance apart. Think of railroad tracks, two sets of tracks, or the rails on each side of a track. Perpendicular lines are lines that form square corners, 90 degrees. So if you just kind of take a look at that, you see the examples of square corners here, square corner 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 here. And there's the symbol, perpendicular lines AB, where A and B form perpendicular contact. Pairs of lines are given special names depending on their relationship. Intersecting, parallel, perpendicular. How can we remember which one is which? Common mistake, thinking that lines are parallel just because they do not touch in a drawing. What would happen if we drew these lines longer in both directions? Let me go back here for a moment. How can we remember which is which? Well, if you look at parallel, you see the two L's right here. That's the way I always remembered it. Parallel has two lines that run parallel to each other. They do not intersect. Perpendicular, I always remember intersecting like an intersection. They go through one another, and not all intersections are perpendicular like this one is. Sometimes they can run through at a different angle. So I always remember intersecting as an intersection, but it could be any way the two lines cross. Perpendicular has to be a perfect 90-degree, it has to form 90-degree angles. They have to cross so that there are 90-degree angles at each corner of the perpendicular contact. So perpendicular to me meant it had to be a perfect square off. So perfect and perpendicular, parallel, and intersecting. Now there may be other ways that they show later in this lesson. If there are, great. Or if there's something that works for you. Some little mnemonic that helps you remember. Okay, so let me show you what happens here if we draw these two lines out. If I take this line and continue it like so, it's intersecting. So even though it doesn't show them intersecting, because that is a line, it goes on forever. So this line would continue here. Sorry, that's not perfectly straight, but you get the idea. That line perfectly, as it continues out, it would be they would be intersecting lines. Which type of lines are the yellow painted lines in the middle of the road? Pause, answer, and then play. Oh, you're right. Those are parallel lines. They are parallel lines. Which type of lines are formed because of the way these roads meet? Pause, answer, and come back. Okay, if you got perpendicular, no. If you got parallel, no. If you got intersecting, bingo, those are intersecting lines because there's no right angles formed there. What type of lines are formed because of the way these roads meet? They're perpendicular lines. Describe the relationship between AB. Now those are line segments. These are not lines. These are not lines. These are line segments because there are no arrows at the end. So those are line segments, AB and CD. And we'll come back and answer that one in a moment. Using the grid lines. Now again, if you have grid paper at home, great. If you don't have grid paper at home, just do the best you can on any other work. But you have this in your math notebook. Using the grid lines, visualize a right triangle that has AB as its longest side. Discuss with your neighbor or with somebody in the house. Okay, so AB, that's the longest side of a right triangle. So there are the other two sides of a right triangle. Okay? Shade in this triangle and describe its base and height. So its base is almost 3 units and its height is 2 units. Can I shade a similar triangle for CD? I think so. And there it is. 2 units height, 3 units length on the base. And it is a right triangle. It forms a right angle in that corner. And this forms, I made that too big, this forms a right angle in this corner. What do you notice about these two triangles? Well, they are congruent. They are the same size and shape. What do you notice about these two line segments? These two line segments, what do you think? Are they perpendicular? Are they intersecting? Are they parallel? If you drew these out continuously, would they intersect? No, not at all. So they can't be either parallel or perpendicular. Perpendicular or intersecting. They are, in fact, parallel. How far apart from point A? How far apart is point A from point C? Well, here's point A. Here's point C. So you're measuring the distance. Remember, it's not inches, feet, miles. It's just units. So in this case, it would be 1, 2, 3. 3 units. How far apart is point B from point D? B and D. Same process again. 1, 2, 3. 3 units. Describe the relationship between AB and CD. I think we already did that. Line AB or line segment, whatever. Line AB. Line AB is parallel to line CD. AB is parallel. That's the parallel symbol. 2 lines running together. AB, line AB is parallel to line CD. Describe the relationship between line EF and GH. EF and GH. Pause and come back with your answer. Okay. If you got perpendicular, no. If you got intersecting, no. They are parallel again, because if those continued out in either direction, they would not ever come in contact with one another. They're running side by side, so they are parallel. Line EF is parallel to line GH. So again, you would write it like this. Line EF is parallel to line GH. Describe the relationship between line IJ and line KL. IJ and KL. What happens if we extend the lines? Can I make one of the triangles inside the other? First, let's extend the line. Let's extend this line. Ooh. Okay, see what happens. So that tells us they are not parallel. They are not perpendicular because they don't make a 90-degree angle as when they meet. It is an intersecting line. So the relationship between IJ and KL, lines IJ and line KL, is that they are intersecting lines. And can I make one of the triangles inside the other? No, you can't. IJ intersects KL. So you'd have to write that one out. Line IJ intersects line KL. Make sure you're writing all of this down in your math notebook. If it shows the notebook symbol, as you know, you write that into your notebook. Describe the relationship between line MN and OP. What happens if we extend the lines? Can I make one of the triangles inside the other? If I extend this line, well, they just continue to run side by side. And I can't, let me go back. Okay, they continue to run side by side, so we can say they are not intersecting, they are not perpendicular, they are in fact parallel. Can I make one of the triangles inside the other? Let's take a look. Yes, you can. Sorry. Yes, you can. There's a right triangle for MN, and you've drawn that same right triangle inside here. So describe the relationship between the line MN and OP. They are parallel lines. MN is parallel to OP. Please make sure you're including all of this in your notebook. Identify if the angles are perpendicular. Here's our little protractor. Again, if you measure the angle where the lines meet, if it's 90 degrees, if it's a 90-degree angle, a right angle, then the lines are perpendicular. If not, they are intersecting. But in neither case are they parallel. Parallel lines do not make contact, so there is no angle to measure. So let's try A. A, you place one line and have it right on the baseline, 0 degrees, and then the second line should be 90 degrees, and it is 90 degrees. Therefore, A is perpendicular. B, again, there's the baseline on 0 or 180, 0 or 180, and this line should measure at 90, and it does measure at 90, so that is perpendicular. If you have a protractor at home, get it out and practice with it, play with it. Perpendicular. C, okay, C, we've got, there's the baseline, and here we have, oh, that looks like about 95 degrees, so it's not 90 degrees, it is not a true right angle, therefore it is not perpendicular. And D, there's the baseline. You always start with the baseline. Start by lining up one of the lines as the baseline. You could do this either way. You can use either one of these as the baseline, but it's always best to use if one line is longer than the other, use one as the baseline and the other as for the height. And this looks like about 80 degrees, so this is not perpendicular either. Okay, go back and play that again if you need to look at that again. It says, well, it's right here. Line up one line with the 0 or 180. It goes all the way through this baseline, and then see if the second line matches up to 90. And there's not perpendicular. Okay. Closure. What does perpendicular mean? What does parallel mean? Practice the arm motions. Okay. Pause there for a moment. and come back with your answers. Okay, you're back. What does perpendicular mean? It means that they cross and form right angles, four right angles where they meet, and when measured, it is a 90-degree right. It's a 90. They meet at 90-degree. They form 90-degree angles when they meet, and you can make that little hand cross thing where you make make a nice square where they meet, or a nice straight 90-degree angle where they meet. What does parallel mean? It means they run side by side. You can run your hands up and down so they stay side by side. And remember, intersecting lines mean that they cross, but they cross in any way, but not making 90-degree angles where they cross. And practice the arm motions. All right. Well, that's the lesson on intersecting, perpendicular, and parallel lines. Hopefully, you understand it now. If you have any questions, go back and play it again. Hope you enjoyed this video. I enjoyed producing it. You all take care. Thanks for participating.